Okay, so for number 1 on the free response section, we need to use Taylor's formula to find a Taylor series expansion. So our function is e to the negative 3x, and our centering point is 6. So we need to know, first of all, what is Taylor's formula? That's something you should absolutely have memorized for this test. Remember that Taylor's formula is the infinite series from 0 to infinity. So what we have is the nth derivative of f at a. So this means n derivatives, not exponents, of f evaluated at a times x minus a to the n power all over n factorial. So that is Taylor's formula. So we need to use that to just find our Taylor series expansion for this function at this point. So what we need to do is, now in general when you do these you're going to want to write them in series notation if possible also. So let's try to keep it in series notation. So first let's see what happens when you do derivatives of f of x. You can see here you have e to the negative 3x. Every derivative that you do of this is going to just pull a negative 3 in front, and it's going to keep doing that. The e to the negative 3x part will always be there and it will not have changed. So the nth derivative of x is going to be negative 3 to the n e to the negative 3x. So what this is saying is however many derivatives of x, or however many derivatives of f of x I'm taking, that's how many negative 3's are going to have been pulled down. And you're just going to have them multiplied times each other, so you have negative 3 to the n. That e to the negative 3x always stays there. But what are we doing? We're doing the nth derivative at a, and a is 6. So everywhere there's an x in here, we're going to be plugging in 6, which is only right there. So we get negative 3 to the n e to the negative 18. So this part right here is our nth derivative of a. The other two parts are pretty self-explanatory. So what we can write here is our new series with this correct information. So instead of f, nth derivative of f at a, we can substitute this. Now, e to the negative 18 is just a constant, so that even doesn't have to be in the series. We can pull that out, and this just becomes negative 3 to the n. Now also we have x minus a to the n. Our a is 6. So that just becomes that. And on the bottom we just have n factorial. That doesn't change anything either. So that is correct. Chances are your teacher would probably want this written slightly differently. It's just customary when writing series that if you have some sort of alternation, you separate the alternating part out. So we would have negative 1 to the n. And since we have 3 to the n and x minus 6 to the n, we could combine those by distributing that 3 and get 3x minus 18 to the n. If this were, for example, a multiple choice problem, this is more likely what you would see. But you can see this is the exact same thing. I just distributed the 3 in there and left the negative 1 to the n, the alternating part, by itself. And this has the e to the negative 18 outside. So this would be your Taylor series expansion for this function at that a.